Hello and welcome to this session. It is great to be here again at the Knowledge Graph Conference, and I hope everyone is having a great time. I am Melly Annamalai. I'm a product manager with Graph Technologies at Oracle. And today I would like to share with you some thoughts on multi-model, multi-workload infrastructure for developers. So one challenge that developers have is that they need to work with different data types, different data models, different data workloads, often within the same application. And then talk about the tools that are available to work with graphs in such a multi-model database. And then I'll touch upon some customer use cases. So for this session, I'm going to kind of use an application that I'm going to call Oracle Movie Stream. That is a fictitious company that allows you to stream movies on your devices. So there are customers who subscribe to the service and have the ability to view movies. So when you build such an application, what are the types of things that an application developer would like to do? So they would like to perhaps work with many different data types and many different data models. And let's look at a few examples. Their customer sales data is likely to be in a traditional database, like who rented which movies, how many movies they have rented, and so on, and customer demographic information, and so on. Geospatial information, that's customer location information that will help give the company insights into where they're having some traction, which geographical regions they need to focus on, and so on. Perhaps there's a lot of unstructured information as JSON documents, which include information about reviews for these movies, awards this movie has won, and such information very relevant to this business. Perhaps they want to apply machine learning techniques to make movie recommendations. And perhaps there's a movie ontology represented using an RDF graph to make better movie recommendations and so on. So an application developer looking to help customers have a good experience and to help the company get new insights into the customers have to work with these different data models and different data types. So Oracle Database is a multi-model, multi-workload data platform that enables developers to work with relational data, a graph representation of the data, JSON documents, geospatial data, and more. So the application developer doesn't have to go looking for a particular platform to work with a particular data model. They can work with all of these data models within the unified database platform, and they don't have to unnaturally stuff one data model into another. Like some data is best represented relationally. Some data is best represented as a graph. And they can do all of this within the same database. And when they create a new database, they don't have to decide that these are the data models I'm going to be working with. They can create a generic database and add new data models as their application requires them. The database also has support for multiple workloads, like transactional workloads, analytical workloads, applying machine learning, event processing, like the database, for example, can connect to Apache Kafka to read directly from Kafka Stream. So if input data is coming in real time from Kafka Streams, the database can read and ingest that data. So database can work with multiple workloads. So it makes it really easy for a developer to have one single unified infrastructure for managing multiple models and multiple workloads. And when they're working with these different models, they can use SQL to access these different data types or REST APIs, or they can use model-specific languages. For example, if they're working with RDF graphs, Sparkle would be, of course, the language of choice. If they're working with XML data, XQuery would be the language of choice. So developers have a choice of either using SQL to query graphs, to query JSON, to query relational data, or they can use model-specific data languages for querying and accessing data in these different data models. So when it comes to graphs, of course, we are focused on the graph query languages, SPARQL, which is the standard. And for property graphs, we are participating in the SQL PGQ committee for creating SQL extensions for working with property graphs. Till such time, we're supporting the property graph query language that is aligned with the standard. So it's a graph query language, and we'll see some examples of this in the demo. So application developers working with graphs, we find that customers tend to either want to use RDF graphs because they have an RDF graph background, and they feel that that's the best tool to solve their business problem. And also linked data applications and so on, they naturally fall into the RDF graph category. And then we see customers who are interested in running graph analytics. They want to represent their data as nodes and edges and apply analytics algorithms like PageRank or Dijkstra shortest path and get new insights into their data. So they all fall into the property graph category. And the database, being a multi-model database, can support both of these models. There can be a single source of truth. You can create an RDF graph or a property graph from this single copy of the data. And data can be combined, and the graph models can be converted from one to another. You can create an RDF view of a property graph and a property graph view of an RDF graph. So it's very easy to work with both graph models and move from one to the other. So there are a variety of tools available for application developers to work with these graph models in an Oracle database. The recently released RDF Server and Query UI provides a simple way to run queries, and I will show that in a bit in the demo, and also includes a REST API for setting up a SPARQL endpoint. Oracle SQL Developer is a tool that is hugely popular with SQL developers, has millions of downloads, and folks who are familiar with that tool can use this plugin that we have for running SPARQL queries within Oracle SQL Developer. So that tends to be a popular option as well. And in the property graph side of things, we are excited about Graph Studio, which we are right in the midst of releasing. It's available in some regions in the Oracle Cloud. I think it's being rolled out to all regions now. Graph Studio includes an automated modeler for creating a property graph from relational tables, and also includes a notebook UI for running graph queries, running graph algorithms, and so on. And on the RDF graph side of things, for popular frameworks like Eclipse RDF4j, Protege, Jena, we do have adapters. So a quick overview of the property graph feature and the RDF graph feature. So the property graph feature includes an in-memory graph server that is specially designed to run graph analytics at extremely high speeds, so it can scale to billions of vertices and edges. It includes support for the property graph query language, which is a SQL-like query language for specifying graph patterns. It includes over 60 pre-built algorithms that you can just call with a simple API call. You don't have to code these algorithms in your Java code or Python code. You can just call these algorithms and apply algorithms like PageRank, whom to follow, shortest path algorithms, community detection algorithms, and so on. And all of this is built on the enterprise capabilities of Oracle. And in the RDF graph feature, we have a comprehensive support for the W3C standards, RDF, OWL, SPARQL. Once again, it can scale to billions of RDF triples. You can store the graph in memory for a speed up of queries. And it's typically used in linked data applications or folks who want to include an ontology in their queries and so on. And again, built on enterprise capabilities of the Oracle database. So I'm going to now show how an application developer would now use the relational model, which stores customer transactions, an RDF graph model, which stores movie ontology and other information, and a property graph model to analyze customer preferences. We'll see how an application developer can use these three models and the tools that I was just talking about as they develop their application for Oracle Movie Stream. So let me pause this here and now share a different screen. So I just logged in here, and now I hope you can see the screen. And now let's say I can select first my RDF graph. And once I select my RDF graph, I can look at the different RDF network, I'm sorry, I can look at the different graphs that are available for me to use. So I can select this graph and then open this dashboard and run this SQL, this Sparkle query here. So I run this Sparkle query, I can get the results, I can look at this graph visually, and so on. So let me now run a few other Sparkle queries. So I'm running a Sparkle query now to find all the genres of movies that Keanu Reeves has acted in. And you can see here the list of different types of movies that he's acted in. And I can use an ontology that represents the different genres of movies in a query such as this. So let me run another Sparkle query here, where I'm going to find out all movies that Matt Damon has acted in that are more than 150 minutes long. And I get a list of movies here. And now let me now create a co-star graph so that we can identify all the co-stars that a particular actor has acted with. So yes, I am, okay, here's I'm identifying all the co-stars that a particular actor has acted with. I can visualize this results as well. So you can see here that this is a simple dashboard to run Sparkle queries, visualize the results, and also you can do things like import data. You can upload data from a file. We support like popular formats like Interpol and Turtle formats. You can create new graphs, you can query existing graphs, and so on. So now let me move on to a different tool, which is now SQL Developer. Where's my SQL Developer window? Okay, here it is. So now I'm going to use SQL Developer to run a different kind of query. So this is a Sparkle query that is finding all the movies that Tom Hanks has acted in that belong to the genre comedy. And because we're using an ontology, it's genre comedy can include things like comedy, drama, romantic comedy, and so on. Many different categories can come into that. And then I'm combining that with the SQL here to find out how many movies this customer, this has been watched by customers at Oracle Movie Stream. So I'm using the Sparkle query to find the movies that belong to a particular genre that can link in an ontology. And then I'm using a standard SQL query to then find the number of times these movies have been watched by customers. So I'm basically embedding this Sparkle query within a SQL query to combine the relational model with the RDF model. So when I run this query, I get a list of movies that belong to the genre comedy that Tom Hanks has acted in, and here are the number of times these movies have been watched. So next, I am going to switch to property graphs. Where is my property graph window here? Okay, here we go. So here, I am now logging into my Graph Studio portal here. And this is the tool that's available in the cloud. And I'm going to start by creating a graph. So in the automated modeler, I can then identify the tables that I want to use while to create a graph, the customer table, the customer sales table, and then the movie table. Because I'm going to look at this information, create a graph, and use the graph to make recommendations for movies for a particular customer. So it identified automatically the vertex tables and the edge tables based on the foreign key relationships. And here's the syntax if I wanted to change that graph that is created. And then I click on next, and then I can, once I'm sure that this is the graph I want to create, I can go ahead and create the graph. And then I can open a notebook and run some property graph queries and analytics on this graph. So the first query that I have here has 2 customers, and I'm going to find all the movies that they've both watched. So basically finding the overlapping movies, right? The exact set of movies that both these customers have watched, and I'm representing that in this graph. A couple more examples here. I'm running a query. This is just a simple query. Find me movies that someone has watched. That's a radial representation. The same query, I'm representing it differently visually, the concentric representation. And now I'm going to run graph analytics. So I first get a handle for the graph in memory. And then I'm going to run the whom to follow algorithm. And you can see here that I have 151,000 nodes and 18 million edges. So in the whom to follow algorithm, what I'm going to do is I'm going to select a customer that I want to run this algorithm on, and then I'm going to run this algorithm. So what this algorithm will do is it creates communities of customers depending on the movies that they have watched. And then it looks at the link structure within these communities to make recommendations for a customer. So it's not just look, of course, when you look at 2 customers, it's obvious that 2 people like certain set of movies. That means that person is going to perhaps like other movies that this other customer has watched. But what we're doing here is creating a community of users, communities of users, and then making recommendations based on the structure of the customers within the community and which movies they have liked. So I run this query. You can see again, it's a simple API call, whom to follow, that I'm calling there. And then I get some results that I can now query. Again, I'm just using Java snippets here. So I'm first listing all the other customers that are in the cluster, in the same cluster as the customer I'm working with, that is Amal. And next, I'm going to get some movies recommended for this Amal based on the community that she belongs to. So it's now going to list me movies that would be recommended for this customer. And if I take a look at the Lion King in this query, PGQL query, to verify that there is indeed a connection between the Lion King and customer Amal, I can see here there is a connection. It's not a direct connection, but there is a connection as represented by the dotted line. And there are 2 ways in which the Lion King is recommended for this customer, which is interesting. So it's and then here is another movie, Lady Bird, and here again there's a connection, and it's a single connection. It's a dotted line again, so it's not a direct connection, but there's one way in which the movie Lady Bird is recommended for this particular customer. So now with that, let me get back to my presentation. And let me go back to now customer. Let me continue with customer use cases here. Okay, so let me continue with customer use cases. So I'll start with Ordnance Survey, which is a very classic RDF example. They wanted to link data rather than documents because they wanted to automate the exploration of data. They wanted to represent the same set of features with different resolutions. They also wanted to capture provenance information. So their source data was in a database. They mapped that to RDF using the R2RML specification. And what they were able to do easily is do all of these operations within the same infrastructure, because the source data was in a database, And then they're able to create a graph, link in some ontologies, and then use GeoSparkle, SQL, and Java APIs from their applications to access this data. They didn't have to go find different vendors. They didn't have to go find they didn't have to use different platforms. They were able to do it all within the Oracle database platform. And again, to highlight in the demo, as I was showing, both the RDF graph queries, the property graph queries, they're all working on the same platform with the same set of tables. And here is an example of what some users are doing, which is interesting. They're creating a data model based on RDF. And since RDF is schemaless, it gives them the flexibility to change their schema as the data evolves and the application evolves. So they create like a pile of basically RDF triples and then build relational views on this data for use in their applications. So to quote my colleague, this liberates them from a rigid schema that they have to define at the beginning, but they don't know how their application will evolve. It also has the advantage that rules about the data are with the data and not embedded in application logic, and they're able to do all of this by building on other Oracle features like high availability and security and so on. Keshav Bank is using RDF graphs to manage their product catalogs. And they have a large number of products that Keshav Bank offers, and they have custom information for each product. And this changes. So products can have new attributes, new information is added dynamically. By having an RDF graph representation, they didn't have to modify the database structure every time new information was added. They're able to have a generic infrastructure that could be reused for different applications. And also, they're able to identify relationships between products, between different product components, because graphs can do that really well. Graphs can help you find relationships between your data entities, and their source data is in tables. They create an RDF graph representation. And once again, they're able to do that within an RDF, within an Oracle database infrastructure. So another system that is in production at Keshav Bank is something that's based on property graphs. So they represent all Keshav Bank users as nodes in a graph. And every time there's a relationship between two customers, that becomes an edge in the graph. And the relationship is defined as, for example, two customers swipe their credit cards at approximately the same time. This could be two friends going out to lunch and paying for their lunch using their credit cards. And they want to identify this as a relationship between these two customers. Or maybe two customers had some kind of a money transfer between them for a social activity, such as gift for someone, for a common friend, or maybe they went on a trip together and things like that. So they want to build these communities based on social networks. I should say they want to build this graph based on the social relationships between customers. So every time they identify an edge, a relationship that becomes an edge, and then they have every user becomes a vertex or a node in the graph. And this is a large graph. There are over 400 million vertices and 2 billion edges. And then they want to run analytics algorithms to detect communities within this large graph, because communities have similar interests, likely similar incomes, and likely to buy similar products. So they have this graph used by many applications, by data scientists, by business analysts, and so on. And once again, they start with database tables, create a property graph from these tables, and then make this graph available to their applications. So they run this specialized graph algorithm to identify the communities, and not surprisingly, customers belong to overlapping communities. And also they found another benefit for doing this. So some of their customers, there might be incomplete information, such as a credit score might be missing or some income information might be missing. But looking at the community the customers belong to, they're able to identify information about this customer. Like if 80% of a community has an expensive smartphone, then perhaps that tells us something about the income level of that particular community. And they're able to use this to have better predictive models based on the information they gather from graphs. They're identifying newer and newer information about new use cases for graphs to identify fraud, detect mule accounts, Like when money goes through mule accounts, perhaps some money laundering is going on. So by looking at how things flow in a graph, they're able to identify all kinds of interesting insights about their data. Risk propagation, if you have different companies dependent on each other, and one has a problem with the supply chains, that is likely to propagate to other companies connected to this company, and so on. So by representing data as a graph and making explicit the relationships between data entities, they're able to get new insights into their data, and they're finding all kinds of applications that they can that have use for this type of graph analytics. So to summarize, developers can work with multiple data types and data models and workloads in Oracle database. It's really easy for them to have one unified platform. It eliminates fragmentation, and they can develop their application with data that is integrated. And it is easy to merge technologies such as graph with relational and other technologies, and have, again, a unified view or unified application that integrates all of their data. And I should mention again that all of this is available with a database license. There's no additional cost. A database license includes all of these features. And I would like to acknowledge my colleagues for help with the demos and other aspects of the presentation. And now it's time for Q&A.